Bismillahirrahmanirrahim. In today's video lecture, we discuss the exact differential equations. We know that we study the first order and first degree differential equation, and we know that this is the dy by dx is equal to f of xy is the explicit form of first order and first degree differential equation. So this differential equation, this is the first order first degree differential equation, and this differential equation is exact differential equation. If we write if f of x is equal to m is function of xy over n is function of xy. So we break or we write this function f of xy is equal to m over n, and m is also function of xy and n is also function of xy. For example, if we have x raised to power 4, then x raised to power 4 over x raised to power 4 y. So then we can write this function in this form. So we write this function in this form like x raised to power 5, y raised to power 2 over and x y. So we write this function x raised to power 4y in the form of this. So in here, this is our m of xy and this is our n of xy. It means we write f of xy in this form. If we are able to write f of xy in this form, then we proceed further. So we put the condition here: if f of x is equal to minus m of xy over n of xy, then this is our equation number 1. Then equation 1 becomes, so substitute this function in here. So the equation 1 became dy by dx is equal to minus m is function of xy over n is function of xy. So we write this explicit form in the differential form. So we convert this form into differential form. So in differential form we write n is function of xy, dy is equal to minus m is function of xy dx. So this is the differential form of equation 1. So we rearrange these terms. So this become m of xy dx plus n of xy dy is equal to 0. So this is the differential form of our equation 1, and this is the first order and first degree explicit form of differential equation. We first convert this explicit form into a differential form. So this is the differential form of first order first degree differential equation, and this equation we write or name, this is equation number 2, and this equation number 2 is exact if this equation 2 is exact if and only if partial m over partial y is equal to partial n over partial x. if partial m over partial y is equal to partial n over partial x, these both partial derivative of m with respect to y, and this is the partial derivative of n with respect to x. If these both derivatives are equal, then we say that equation 2 is a exact differential equation. So this is the test for exactness. This is the test for exactness. So this is the another type of first order and first degree differential equation, and that is a exact differential equation. So we uh, just check by example, like if we have example and we check the given differential equation is exact or not. So this is x cube plus 3xy square dx plus 3x square y plus y cube dy is equal to 0. Now we check this is the exact differential equation or not. So the first step is comparing given differential equation with the general form of differential equation. This differential equation, that is a differential form of first order first degree differential equation, because we comparing with 2, comparing with 2, then we get m. And what is m? Comparing this the coefficient of dx is m and the coefficient of dx is m, so m is x cube plus 3x y square, and coefficient of dy is n and coefficient of dy is 3x square y plus y cube. So we check the test of exactness. So test of exactness is partial m over partial y is equal to partial n over partial x. So we calculate the partial m over partial y. So this is equal to partial over partial y x cube plus 3xy square. So partial y x cube partial over partial y 3xy square. Okay, so this is the x square and we take the partial derivative with respect to y. So x behave constant, so derivative of constant is 0, and 3x is also constant because we take the derivative with respect to y. So this is equal to 3x behave constant, and derivative of y square is 2y with respect to y. So our net answer is 6xy. Now we take the partial n over partial x. So this is equal to partial over partial x 3x square y plus y cube. Now the 3x square is y behave constant, 3 behave constant, so derivative of x square is 2x with respect to x, and derivative of y with respect to x is 0. So partial n over partial x is equal to 6xy. So from here and here, partial m over partial y is equal to partial n over partial x. So which prove that the given differential equation is a exact differential equation. So if you now the given first order first degree is exact differential equation by using this test of exactness, then we move on a second step, and that is the solution of exact differential equation. So in the next video we will discuss the solution of exact differential equation. And in this lecture, I just focus on the definition of exact differential equation and the test of exactness. And in the next step, we will study the methodology or solution of how to get the solution of exact differential equation. And thank you so much. Bismillahirrahmanirrahim. In this method, in this lecture, we will discuss the method to find solution of exact equation. So the first method is we have different methods to solve the to find the solution of exact differential equation. So the first method is using formula. Using formula. So first we know that first we write our exact equation. So that is the general form m of xy dx plus n is function of xy dy is equal to 0. If this equation is exact, if this equation if this equation is exact, then its solution formula is, this is integral m is function of xy dx. First we write the integral, or we integrate the m with respect to x. Partially integrate the m with respect to x plus integrate terms in xy without x dy is equal to c. So this is the formula to find the solution of exact differential equation. Again I repeat, first we check the given equation is exact or not. If given equation is exact, then we move on its solution, and its solution formula is integral integrate m with respect to x plus integrate n, but we take the terms of n without x. So in term we have x, then we neglect the that term, and integrating this n with respect to y and put equal to c, and then we integrate the both terms and we get the solution. So we describe this solution by using the example, and we take the same example because we know that this equation is a exact equation. So we don't need to again check this equation is exact. So we find the solution of this equation directly. So this equation is, we write this equation x cube plus 3x y square dx plus 3x square y plus y cube dy is equal to 0. So we already know that this is the exact differential equation, and m is equal to x cube plus 3xy square, and n is equal to 3x square y plus y cube. So we're using the formula here. So integrate m, so x cube plus 3x y square dx plus integrate n, but we take the terms of n that have no x. So in the first term x is available, so we neglect this term, and in the second term no n, so we take this term, and this become y cube dy is equal to c. Simply we integrate this, so x cube dx plus 3y square is behave constant because this is the partially we integrate partially. So how to integrate this? So this is equal to x 4 over 4 plus this is equal to 3y square x square over 2 and plus y 4 over 4 is equal to c. So we also take the LCM 4. So this is x to the power 4 plus 6x square y square plus y4 is equal to c, and this is x to the power 4 plus y to the power 4 plus 6x square y square is equal to 4c, and we also write this x raised to power 4 plus 6x square y square plus y4 is equal to c1. So this is the solution of our first order, first degree exact differential equation. So we find the solution. We find the solution of this exact differential equation by using the formula, and the formula is very simple. Integrate m with respect to x plus integrate n with respect to y, but we keep in mind we take the terms of n without x and put this bottom is equal to c and simply partially integrate it. No worries to this term, this y square, because we integrate with respect to x, but y square is available. So y square in here behave like a constant, like 3 behave like a constant. So 3y square is outside the integration, and we simply integrate the given term. And the same thing is here, we integrate this with respect to y. So and this is so simple. So this is the method to find or to deal with the exact differential equation. Again I repeat again and again, first we check the given equation is differential or not, exact or not. If given equation is exact, then we find its solution. And how to find its solution? We find its solution by using this formula. And students, you must memorize this formula if you want to deal with the exact differential equation. We have another methods also, but this is the simple method to find the solution of exact differential equation. So we take another example and check the given differential equation is exact or not. First we apply the test and then we find its solution if the given equation is exact. So I take another example. So this is another question. So we check this equation is exact or not. So first we comparing, we call this is equation 1, and comparing with g, comparing with m dx plus n dy is equal to 0. So we get m is equal to 2x e raised to power y plus e raised to power x, and n is equal to x square plus 1 e raised to power y. So we check this differential equation is exact or not. So in the second step, we apply the test for exactness. So we check the test for exactness here. So that is partial m over partial y is equal to partial n over partial x. Okay, so we first find the partial m over partial y. So partial m over partial y is equal to partial y 2x e raised to power y plus e raised to power x. So this is equal to partial over partial y 2x e raised to power y plus partial y e raised to power x. So 2x behave constant because we take partial derivative with respect to y, and derivative of e raised to power is e raised to power y, and derivative of e raised to power x with respect to y is 0. So partial m over partial y is equal to 2x e raised to power y. Now we find the partial n over partial x, and this is equal to x square plus 1 e raised to power y. Sorry, partial over partial x. So e raised to power simple behave constant, and partial x square over partial x plus partial 1 over partial x. So we find the derivative here, and that is 2x, and derivative of 1 is 0. So this is partial n over partial x is equal to 2x e raised to power y. So both are equal. So this implies partial m over partial y is equal to partial n over partial x. So this implies equation 1 is exact, or simply exact, or exact differential equation. Now we find its solution. And simply put the formula integral m dx plus n a term without y dy is equal to c. So what is m? M is yes, 2x e raised to power y plus e raised to power x dx, and we want to write the n, but we don't take we didn't take the terms of terms with x. We don't take terms with x. So if we multiply if we multiply e raised to power y with x square, so this term contain x, so we neglect this term. And if we multiply e raised to power y with 1, so e raised to power y with 1 dy have no term of x. We simply integrate this, and we direct integrate. So this is so simple. This is 2 a raised to power y behave constant, and integration of x is x square over 2, and integration of e raised to power x is e raised to power x, and integration of e raised to power y is e raised to power y. So these twos are cancel out, and this become x square e raised to power y plus e raised to power y plus e raised to power x is equal to c, and we also write e raised to power y x square plus 1 plus e raised to power x is equal to c, and this is the solution of our exact differential equation. So hopefully you understand the concept of exact differential equation, test for exactness, and its solution by using the direct integrating formula. And in the next lecture we will study the equations are not exact, but by multiplying by some integrating factors, that equation become exact. So in the next video lecture we start the next theory of exact equations. Thank you very much.